Okay, good morning, good afternoon, good evening, depending on where you are in the world. Really good to have you with us today. There's so many of you. I guess there are a lot of people who are facing the challenges of SQL queries and BI analytics taking way too long. Before we begin, can you just show a raise of hands if you hear me okay? Excellent, excellent, good. So I'm really happy to be here with you. My name is David Leichner. I'm the CMO at SQream. And for the next, say, 45 minutes, we'll be discussing some of the issues that companies are facing with regards to SQL queries and BI analytics that are taking way too long. So a little bit of housekeeping. If you'll notice, there's a place to ask questions, and there's also a chat. So if you would like to ask a question, and we will be having a Q&A session at the end, please simply go into the question box and put your question there, and I will take as many questions as I can towards the end. And also, there's a chat box, so if you're having problems hearing, if there's some problem, with the sound, something, whatever, then please put it in that chat box as well, and I will see that. So just a couple of other announcements, you could call them. We're going to be at the TDWI event next week in Chicago. And if any of you are planning on coming there, it would be a really good opportunity to meet face-to-face. That's the Data Warehouse Institute event, where we'll be both at the Leadership Summit and we will be at the event itself. The third week of May, we'll be at DBTA in Boston. And again, if any of you are in the Boston area or are coming in for the event, it would be really good to meet up. And the next show after that we'll be at is BDA Big Data in London on June 13th. So if you're planning on attending any of those, you can drop me an email and I'd be very happy to set up a meeting. So let's go and jump right into the discussion of the day. Are your SQL queries and BI analytics taking way too long? So if you're on this webinar, then you are probably experiencing this at some point in your career. Now, I didn't put this on here because I'm a marketing guy. I put this on here because basically, this is what some of our executives are seeing and feeling when they're waiting for their reports. It's a matter of sometimes taking months, sometimes taking weeks, sometimes taking days, and they're not getting what they need. So if we just look at some of the information that we're hearing from data professionals around the world. So for example, whether it's in the banking system or consolidated risk or anything else, collection and analysis of data is critical. We all know that. Big data analytics is key. We have to be able to get to that data, but not just to get to a segment of that data. We want to get to all of the data. Business and IT don't always work together. It's not always easy for us to get the information that we need. And by the way, this is not a problem, that anyone can blame IT for. And we'll see that things have changed over the years. The data is being stored in, let's say, older technologies. And it's just not that easy to get that data out into a situation where the analysts or the data scientists can actually get to it and do the trending and reports that they need. It's really difficult to integrate the data. Some of you who've done and wrestled with multi-joins, complex types of SQL queries know that it's not easy. We're not equipped to handle the growing data volumes. I'd be interested, actually, if you could raise your hands. I'd be really interested to see how many of you are dealing with, let's say, I don't know, 2 terabytes of data. Could you raise your hands? Great. So keep your hands up. And how many of you are dealing with 500 terabytes? Actually, pull your hands down. How many of you are dealing with 500 terabytes of data? Okay, there are, wow, tens. Okay. How many of you are dealing with hundreds of terabytes of data? Okay, so I see most of you have at least hundreds of terabytes. And under 100 terabytes of data? Okay, great. All right, well, that helps a lot to set the stage. So really, what I'm seeing here is that many of you are dealing with extremely large data stores. So for example, in the consolidated risk area, we know that people are wrestling with bringing in information from different silos, money laundering, going back and looking at the historical data, trying to uncover people who are fraudulent. If we're talking about banking on the customer side, then it's coming up with new products and services. If we're looking at healthcare, there are things like everything from inventory control to looking at the historical medical data, tying into the systems in the hospitals, tying into the HMO systems, being able to go back years, being able to analyze and really, let's say, cross-trend between different diseases and the geographical or demographical makeups of the patients. Many challenges. Other things that we're looking at here is an example from Thailand, and we'll talk today a little bit about one of the mobile operators there, one of the largest mobile operator in Thailand, who's actually working with big data in order to uncover information about the premier users, students, to be able to give products and services and new products and services to their customer base in order to increase ARPU, in order to keep their customers happy. We'll go more into that as we go on. And of course, online customers that we have who are looking at everything from understanding historical data, especially now with the all the mergers that are taking place. We see that there are disparate systems that have to be put together, have to be integrated, really complex types of queries that have to be done. And so it really doesn't matter if we're talking about ad tech, if we're talking about telecom, if we're talking about banking, if we're talking about retail. What is across the board is that we're talking about terabytes and terabytes and petabytes of data that needs to be accessed, that needs to be stored, or I should say stored, accessed, and analyzed. So it's not something new to you, I'm sure, that over the last, let's say, 10 years, CPU technology has kind of, let's say, leveled off. And really, having CPU technology that can handle petabytes of data requires, let's say, a very large data center with many nodes of the data warehouse that you're using or the databases that you're using, extremely expensive to maintain and not so much less expensive to, let's say, to upgrade. So in comes this GPU technology, and we'll talk about that in a few minutes. And we'll also discuss how GPU technology is basically changing the way that we are doing computing today. So databases created 20 years ago, right? Were not designed for massive data analytics. Now, I actually started my career working in a company called Information Builders, and we had at the time a product called SQL that was doing enterprise data integration between hierarchical databases, relational databases, being able to report off of that. There is no existing RDMS today that can handle the amount of data that we wanted to rapidly analyze. When we're talking about the rapid, the amount of data, we're talking about massive amounts of data. To me, there should be a new terminology above and beyond big data. It should be called massive data. And massive data, I'm talking about anything from 10 terabytes up to petabytes of data and beyond. So we can't really understand how we can take care of these queries and these BI analytics without understanding what a GPU is. Now, some of you might know, I actually did a question at an event recently where we were giving a seminar, and most of the people in the room, they correctly stated that a GPU originated for gaming and for video processing, and that is actually the case. A lot of 3D graphics were rendered using GPUs. Well, back on August 31st, 1999, NVIDIA, they introduced the first commercially available GPU for a desktop computer called GeForce 256. And that opened up to us a whole new spectrum of what we could potentially do with the GPU. So as you can see here, that early board could process 10 million polygons per second, allowing to offload a significant amount of graphics processing from the CPU. So what are the benefits of the GPU? So the GPU, first of all, the efficiency increases at twice the rate of CPUs. You can go 10 to 100 times faster. It's much smaller, so you don't need a whole big data center to store it, and we'll talk about that as we go into the presentation. 16 GPU servers equal 1,000 CPU clusters. 16 GPU servers equal 1,000 CPU clusters. That's an incredible number. And of course, there is a powerful graphics rendering engine, is very fast data ingestion, and near real-time data exploration. So why is this important about the GPU? Well, we couldn't explain to you about improving and increasing the speed of your queries and the amount of data that you can query for improving, or let's say making your business intelligence as comprehensive as possible without talking about the GPUs. So now let's tie together a little bit what SQream is doing together with the GPUs, and then we'll get into the issue of how we can speed up the queries. So first of all, SQream was founded in 2010. Our headquarters is located in 7 World Trade Center in New York. R&D is located in Tel Aviv, and we have customers in the United States, in Europe, and in Asia. We also have a strategic partnership that we signed with Alibaba Cloud, and we announced it back in February, where actually towards the end of this year, we will be the de facto solution that Alibaba Cloud will be promoting and selling in China, in the Chinese market. You could say it'll be the GPU database of the Chinese market. In addition to Alibaba, we also run on AWS and on Azure. So what happened? So 9 years ago, a crazy engineer came up with a crazy idea and said, hey, why don't we run a database on this GPU processor? Why don't we take enterprise software to a different level by creating and running a GPU, a database on the GPU processor? And people said to him, well, you know what? You're pretty crazy. That's not going to work. You're not going to be able to really handle that. You're not going to be able to do complex joins on a GPU processor. Well, like every startup that's successful, like every idea that somebody comes with and other people say, you can't do that, it's impossible. Well, guess what? He created the fastest solution available for analyzing massive data stores, having the SQream database on top of the NVIDIA GPU. So actually, just a quote from one of the venture capitalists that know the company very well: SQream DB represents a fundamental shift in marrying advanced chip and software technologies to bring to customers a once-in-a-generation advance for exploiting very large data insights. Now, I can tell you that I was on a call yesterday with a particular bank, and we've been evaluating certain queries that they have. And the queries, one of them, I was told, took weeks and several data scientists in order to get the results from those queries. And when we showed them what we did on our GPU database, we actually were under a minute in that same query. Now, that's fine. We did it here. You don't have to believe it. We'll talk about other use cases as we go on. So what is SQream, the database? So first of all, as I mentioned, we're powered by GPUs. We're a massively parallel engine. We were built from scratch for the GPU. So it's not like we took a different database and ported it over to run on GPU technology. We have patents and algorithms that are specific to leveraging and maximizing the processing throughput of the GPU. We're extremely fast, where we have a columnar storage, and I'll talk about that as we go on. We can ingest 2 to 3 terabytes an hour. We can scale from 10 terabytes up to petabytes with ease. Basically, you would just add more GPUs, more storage. And one of the guys at TDWI said to me, one of the chief analysts said to me, of all the things on this slide, I think the best thing is the fact that you guys are SQL database, because a lot of the new technologies coming out today, they're trying to be no SQL. They're trying to move away from SQL. And with 80% of the world's data still in databases that run SQL, he said that doesn't seem to make much sense. And the fact that you guys are SQL based, this is a very good thing. And we're also extensible for machine language and artificial intelligence. So really, what is it that we're looking to do? And this is actually some giveaways that we had, so we put them on the slide. We're looking to tame the query monsters, multi-table join queries, multi-stage queries. These are the things that keep you up at night. These are the things that takes days or weeks or sometimes even longer. Nested queries, slow queries, really long queries. So how does it all work? So are you all with me? Raise of hands. Great, excellent, thank you. So how do we do it? So first of all, we're not looking to come to replace your Teradata, your Exadata, your Netezza, your Greenplum, your other databases. We believe very much that we can complement those and provide you with significant advantage to handling the problem of this session, which is, are your SQL queries and your BI intelligence analytics, your business intelligence analytics, taking you way too long? So the recommended way of working with SQream is that we have what we call a load and go or a lift and shift type of scenario. So let's say you take 100 terabytes of raw data, okay? You move it into SQream. It goes through a columnar process. So we're actually going to be doing several things during that process. We're going to be setting up metadata tagging. We're going to be creating chunks of data. That columnar process then moves into a stage of compression. So we can compress down, for example, from 100 terabyte data store to 10 terabytes. And then we go into data skipping, parallel chunk processing, and the ability to analyze your data. Now, why are we so quick? We're so quick due to, number one, the columnar process. We're so quick, number two, due to the compression, due to the fact that we've set up this metadata tagging instead of indexes. So you don't have to maintain indexes. And we have millions of rows per chunk that we know how to get to. And all of that on top of the GPU processing strength and processing power enables us to be super fast when it comes to massive amounts of data. So just to give you an idea how a typical engagement would work, you would have your MPP database, you would have it in whatever format it's been in for years. If you were going to have to do it, let's say in the old-fashioned way, you would have some kind of a complex ETL. You would have to pre-aggregate the data because you're not going to be doing analytics on 500 terabytes of raw data. You're going to have to aggregate that. You're going to have to set up indexes, cubing, and so on. And when it gets to the dashboard, whether it's Tableau, whether it's Spotfire, whether it's Qlik, it doesn't matter. A lot of those reports are going to be running very slow. Now, you might not even know that they're running slow. You might say, okay, this is taking me 3 hours. Yeah, well, that's what it takes. It takes me 3 hours. Well, I'm here to tell you that a lot of those reports and a lot of those queries, you could actually bring down from 3 hours to several minutes or maybe even tens of seconds. And we'll talk about that in a minute. So how does it work with SQream? Basically, 2 to 3 terabytes of an offload into SQream. As I mentioned, it goes through the columnar process. We create the chunks, we do the meta tagging, and then you have pure, raw, compressed data, and you will be doing the analytics and the reporting and the trending off of that data. So let's look at a few use cases because, I believe that in order to really understand the power, you really need to. I see that there are some questions coming in already. Excellent, good. So yes, we will get to those in a little while towards the end of the session. So let's look at a few of the use cases. So number one, let's look at cost of performance. Okay, there was a benchmark done by a consulting company in the United States on an ACV calculation on 24 terabytes of data, 300 billion rows, 8 different tables with complex nested joins. So we had Netezza and we had SQreamDB. Okay, we were extremely happy to see that the average query time was almost the same for Netezza and for SQreamDB because Netezza has been around for a long time. It's a very good data warehouse. It's backed, by IBM and so on. And we were happy to see also that the compression ratio that we had was also very much in par with what Netezza was able to do. But when we looked at what hardware was necessary, you had 56 S-blades of running Netezza, 8 full 42U racks, 56 S-blades, 7 terabytes of RAM. And what you had with SQream was you had a Dell C4130 with 4 NVIDIA Tesla GPUs, 512 gig of RAM. So if we look at the total ownership here, we have a difference of, let's say, even 12 million. Let's say there was a 10% discount, 10,800,000 compared to $500,000 for the SQream database running the 4 Tesla GPUs. Okay, that's very nice to see total cost of ownership. But let's have a look also at what we can do from a point of view of time reduction. So AIS, we actually put out a press release last week about AIS. They are the largest telecom operator in Thailand. They have 40 million subscribers. So what they wanted to do was they wanted to learn more about their customers that they weren't able to do previously. And they also wanted to cut down significantly on the time it takes to do their queries, their reporting, their trending. So they had Greenplum, and Greenplum was taking 200 seconds to load the data, where we were taking 18 seconds to load the data. Okay, this was a benchmark actually that they did. So we were 11 times faster. When it came to reporting time, they went from 3,600 seconds, whatever that turns into in hours. I think it's 3,600 is 6 hours, down to 46 seconds in their reporting time. So we were 78 times faster. And when we look at the cost of ownership, 40 nodes and 5 full racks, 7,600 CPU cores, $10 million price tag, and a $500,000 price tag for SQream, running on actually an old HP machine with an NVIDIA Tesla GPU, 96 gig of RAM, and 6 terabytes of storage. So this is actually a documented case study with where the press release actually went out last week, and a very nice quote from their VP of architecture. So let's have one more example. And this is actually an example from the United States. So this one is PubMatic. PubMatic are the guys who do the ad tech bidding optimization. So when you see content coming up, when you're surfing around the net and you see all kinds of things popping up, all kinds of relevant content, they're actually doing the bidding for those advertisers and the publishers who are paying to have that content come up on your website. So as you can see here, they had trillions of ad impressions monthly, 85 terabytes of raw data daily that they had to analyze. With SQream, they were able to analyze that data, and it only took 5 minutes for them to construct the bidding histograms when it used to take them 5 hours. Now, their architecture was Hadoop. They would extract data from Hadoop, from Kafka into Apache HBase. They had dozens of Phoenix and HBase nodes, and the queries would take quite a long time. So we extracted the data. It went into an Avro parser. It was loaded into SQream with 2 NVIDIA Tesla GPUs, and we were able to bring those queries down to 5 minutes. So 60 times faster than previously available. They saw that worked, and they decided, you know what? Now we can start looking at more historical data, because the more data that we can analyze, the better the more accurate our results will be. So now they raised it from 85 or 86 terabytes of data to 360 terabytes of data that they wanted to analyze. Once again, raw data, 16 days worth of data to enhance the bid histogram accuracy. So they added 6 GPUs to what they had, and they were able to keep the queries at 5 minutes. because we're able to distribute that power across the GPUs, there actually was no increase in the time that it took to do those queries. So now they're up to 8 NVIDIA Tesla GPUs. They have Cumulo storage, and they're running 360 terabytes of data that they are analyzing. Now, what's extremely important to understand here is that these were previously unattainable results. They were not able to measure, they were not able to do the analytics on 360 terabytes of raw data. So I think here, we have examples of total cost of ownership for companies that are interested in reducing cost. We have examples exactly for what we're talking about today of being able to decrease the time it takes to do analytics, to speed up the SQL queries, to speed up the time in which you are able to get the results, the business intelligence that you need, because the quicker you're able to receive those, the quicker you're able to pass them on. The decision makers are making the decisions. You're able to do your business that much better, and you're able to compete better. And finally, you're able to receive results that you just weren't able to do. And this isn't the first example. We've had examples with various customers that are now able to get results out of their data that they weren't able to do previously. So just looking at to sum up and to add to this a couple of others, we have here, for example, Telecom, which is the largest mobile operator in Israel, where we were collecting data from Ericsson logs, and by collecting that data and being able to scan 33 billion rows with a single GPU server, they were able to uncover where they had overload in their networks, and they were able to optimize those networks. So they were able to reduce call errors by 90%. Now that translates directly into the bottom line of the company. They were able to reduce the call drops by 90%. Over here in the bottom right-hand corner, this is actually probably the most humanitarian example. This is the biggest cancer research center in the Middle East, and they were actually doing cross-analysis of various, I think it's about 350 mutations of DNA and cancer samples in order to be able to proactively identify people that have the potential for, unfortunately, coming down with a particular type of cancer, so that they could actually do testing, and they can recommend testing early on, because the earlier that, obviously the earlier that cancer is uncovered, the earlier that it can be handled. So this was a pretty significant and very interesting use case as well. So what we find is that when we're talking about SQL queries, we're able to analyze 20 times more data. We're able to do the queries 100 times faster. So if you thought you were joining this webinar to hear about how you can tweak your queries to run, let's say, I don't know, 2 times faster, 3 times faster, we're talking about up to 100 times faster on the queries, and we can do it at 10% of the cost. So let's have a look at the architecture. So as you can see, SQream integrates right into your existing ecosystem, whether you have Talend or you have Kafka or Spark to get your data in. We can take data in from any of these into SQream. We interface to all of the popular languages, Java, Python, SQL, C++, and so on. And you can use the visualization tools like TIBCO, Qlik, Tableau, and Jupyter. You can run on Cisco machines, on Hewlett-Packard, on IBM, on Dell, whatever it is that you have. As we mentioned, we have a partnership in place with Alibaba. We'll be actually, we're in the marketplace, the AWS marketplace, as of, it'll probably be this week. We actually uploaded that today, and Microsoft Azure. Now, let's say you want to expand. You start off with 1 GPU box and you want to expand. It's simply a matter of adding the storage and adding additional GPUs. You work with, we work with certified storage companies. In fact, on our website, we have a webinar with XIO that we did benchmarks with. We work with Store One. We've done that for a long time. They're a very good partner of ours. Hewlett Packard, IBM, DDN, one of the bigger storage companies, Dell, and so on. Our GPU technology is strictly NVIDIA, and we very much we've worked very closely with NVIDIA, and we believe that their processors are second to none. And of course, on the server side, Cisco, Supermicro, Dell, and IBM. So it's very easy to try SQream. And I know that, some companies that, they're a little bit wary of trying new technologies. Well, actually, we have an extremely easy way of starting out with SQream. Simply, we have a discussion. We put an NDA into place so that you have no qualms about sharing with us some of the information we need, which is, for example, a use case. Yesterday, I was on a call with a bank in the United States, and I asked a very simple question. And actually, I would like to ask each one of you the same question, which is, what is it that keeps you up at night? Where is your what is the pain that you're feeling? What is it that you really need to you need to improve? And that's something that we would like to help you with, and that's something we believe we can help you with. So we'd need to understand the use case. The use case can be a particular query. It can be a particular report trending information. Today you're querying, I don't know, a week of data. You want to query a year of data. Your reports are taking 3 hours, 4 hours. You want it to take 10 minutes. You want it to take seconds. Okay, then we would generally get a schema from you of a sample of your data. At that point, we would do an internal evaluation. We would validate that we can help you. This costs you nothing. This is a free consultation that we look at what it is that you need to get done. And we will come back to you and say, yes, we can help you. This is something that we can do, and we can do it really well. And the final stage would be basically setting up the POC, the kickoff, the hardware and software recommendations, the ETL process design of bringing the data in. And at that point, we would start to show you the queries that you can run, and you get to see the insights that either you didn't know existed, or how much more quickly you'll be able to access the reports, the data, the analytics that you need. We had a CIO of a very large organization in the US. I prefer not to mention the industry, only because we recently signed a very nice deal for them that they are now using SQream. And when the CIO got in front of the visualization tool, he was just amazed at how quickly he could not only get the data, but drill down. Because all of the data is there as raw data, he's able to drill down, he's able to do all kinds of different views and analysis and trends on the fly. So at this point, I'd like to ask if anyone has any questions, and I'd be happy to take them. I already have a couple that I see here that are in the box. So give me 1 second. I'll just pull this out so I can see them. Okay. All right. So the first question that I see here is, how does SQream actually connect to the MPP databases? Is it via ODBC, via JDBC? Actually, SQream can load data from any data source. It can be flat files like CSVs, it can be Parquet, it can be via Spark, or it can be via any kind of ETL tool like Thailand. So I hope, Mark, I hope that answers your question. There's another question here. Felipe, do you have to load the data into SQreamDB for it to work? Felipe, this is a very good question. In fact, we do. So in order to get really fast performance, if the data resides in a format that's unsuitable for analytics, like say CSV files, or in other kinds of data warehouse types of, I don't want to say row-based, formats, but other types of formats that it might not be appropriate for us to process on our GPU database, it may be too slow to really affect the queries. It may be too slow to really query effectively. So for that reason, we basically load it into SQreamDB. It doesn't take that long. It's 2 to 3 terabytes an hour. And there it's arranged in our unique way using our special sauce, our columnar processing, our setting up of meta tagging, our creating chunks, no index is needed, and then it's ready for online analytics. Okay, any other question? I see another one coming in now. Claire, nice to see. So what kind of industries are you active in? So I think I've shown you a few use cases. And I think, what you've seen already is you've seen retail, you've seen ad tech, you've seen healthcare. We also have in finance. And these customers, as I mentioned previously, they're located also in the United States, also in Europe, and also in APAC. Okay, we have another question here. Okay, Shahim. So Shahim's asking, what is the recommended hardware? Excellent question. So typically, x86 servers with NVIDIA Tesla GPUs, those are the recommended servers. Actually, we're also, it's also possible to work on Power 8, Power 9 from IBM. Basically, what we'll do is we'll design the right hardware requirements for you. We'll work with you. We'll discuss the use case, and we will help to set up the architecture that's right for you. So, for example, a 10-user company will not need the same hardware that a company with 1,000 concurrent user customers will need. And so that's something that, that we will discuss as well. So another question is just coming in. Just trying to read it here. Okay. Okay, so can SQream be used for sub-second, milliseconds, multi-dimension analysis, lots of filters on big wide tables, over 50,000 columns? So the answer is like this. If those 50,000 columns are, let's say at the terabyte or 2 terabyte level, and you're looking for real-time analysis, then you would probably not want to use the strength of SQream, because at that point we would be near real-time. And if you're looking for real-time, then you would probably want to use a different type of solution. But if you're talking about 50,000, over 50,000 columns, then we're probably talking about massive data. We're probably talking about hundreds of terabytes of data. And in that case, yes, absolutely, you would want to have a look at SQream. You would want to evaluate SQream. In fact, we have companies that are using, they have, very, very large columnar databases that we've built up, on the, once we've ETL'd the data in, and they can definitely, we can definitely answer that requirement. Okay, I see another question coming in. Who is the typical customer? Okay, so that really depends on the role in the organization. A lot of times what we see is that the initial discussion would be with a data analyst or a data scientist or maybe the VP of data. Very quickly, the IT team comes in, so we'll be meeting with the IT manager. It could be that we're meeting with the DBA, we're meeting with the person that's running the data warehouse, and then it becomes really a cumulative effort. So it becomes an effort where we will be working together, putting the data into SQream, and then having the data scientists actually run the queries. In some cases, they'll just set up the visualizer, and then the CIO will come in and start playing with it. So it really depends on the situation. So let's see, I see one more question here. This is great. By the way, it's an amazing session. We've got well over 100 people online, and I see that most of you are still there, which is great. So I guess I didn't bore you today. we're looking here at a question, Wilfred, about the price range for a 16 Tesla GPU system. So I think that we really need to take offline, and I'll explain why. It really depends on how many terabytes of data you have, and also where you'll be acquiring the GPU system. So if you're working with one of the companies, one of our partners, so it might be one type of pricing. If you're working with, depending on where the provider is, so that's just on the GPU side. If you're, and then talking about SQream also, this is something we would need to see according to the use case and according to how the configuration is set up. So I think I've exhausted all of the, I'm getting a question here, it looks like in German. Well, I apologize. My name is Leichner, which is actually Eastern European, and actually it's all over the German phone book, but I don't actually know German. My apologies. So what I'll do is I'll take that question and I will take it offline, and we'll get in touch to see if we can get an answer for you. So with that, if there are no more questions, we'll bring this webinar to an end. You have my contact information here. You have my email, david@SQream.com. And I'd be very happy to meet you, as I mentioned, at one of the upcoming events that we'll be attending: TDWI in Chicago next week, DBTA in Boston, third week of May, and BDA London, June 13th. So I'd like to thank you very much for your attention today. And please take advantage of our trial offer. Just drop me an email and say, we want the 4-day POC, and we can have you up and running, next week, the week after, and you can start seeing really how you can speed up those queries, how you can get that BI intelligence so much faster, so that the next time that we run a webinar about are your SQL queries and BI analytics taking way too long, you won't have to join the webinar, because you'll already know how to fix those queries and really, what is the new database of the future. And SQream is there, and we're proving it all around the world, and we'd be very happy for you to join us as well in this program. So thank you very much, and we'll see you at the next webinar.